Today we're going to jump right into reviewing how to factor the following quadratic polynomial. To start out, remember that when we're factoring something, what we are given is what goes inside of the box, and we are now trying to figure out what goes on the outside. So to start out, we know that we can put the x squared, that first term, in that first box, and we can put the 35, that last term, in that last box. The question is, what goes in those middle two boxes? Well, we know that it should add up to 12x, but we don't know what they should be. We need a little more information. So remember, we need to know a, that number in front of x squared, which in this case, it's 1. If I don't see a number in front, I assume it's a 1. B is that middle number, the number in front of x. That would be 12 here. And then C is my final term. Here that would be 35. What I'm going to do with these numbers is I'm going to multiply A and C together. So 1 and 35, which gives me 35. So what I'm going to do is I'm going to look at factors of 35 that add up to 12. In other words, numbers that multiply to 35 that also add up to 12. So if I list the pairs of numbers that multiply to 35, I've got 35 times 1 and 5 times 7. Which one adds up to 12? You can check this yourself using a calculator. 35 plus 1 is 36, and 5 plus 7 is 12. So we are going to use 5 and 7. Where these 5 and 7 are going to go is inside of these two boxes. Now remember, those two boxes add up to 12x. So the 5 has to have an x with it, and the 7 has to have an x with it. Now what's going to go on the outside of the box? Well, I see that x squared and 5x both have an x in common. So I can put an x on the outside. Then I see that this would have to be a 7, so that it, because 7 and 35 both have a 7 in common. On the other side, x squared and 7x have an x in common, so I can pull out an x. And then 5x and 35 have a 5 in common, so I can take out a 5. What that means my answer would be is my answer, oh, I can really see it. It should be x plus 7 times x plus 5. Okay, now just to review that stuff again, because I know the GCF stuff confuses some people. All right, x squared and 5x both have x. They both have at least one x I can take out, so I'll take out an x. 7x and 35. Both 7 and 35 are divisible by 7. Okay, then if I look at the other side, x squared and 7x, what do they both have in common? An x. What do 5x and 35 have that they can both be divided by? A 5. And so the stuff on the outside of the box goes inside of the parentheses. X plus 7 times x plus 5. So today we're talking about factoring and using the factoring to help solve these equations, to help us figure out what x is going to equal. So we're going to talk about factoring quadratic equations and then determining the solutions to these quadratic equations by using the zero product property. So the zero product property, think about it. If you have two numbers multiplied together equals 0, and one of the numbers is 2, what would that other number have to be? Okay, well, any number multiplied by 0 would give you 0. So in this case, 2 times 0 would have to equal 0. One of the other number would have to be 0. All right, so the zero product property states that for any numbers, if two numbers multiplied together equal 0, then either the first number is 0 or the second number is 0. So this is kind of what we're using today. If I have two factors, stuff in parentheses multiplied together equaling 0, then either the stuff in the first set of parentheses has to equal 0, or the stuff in the second set of parentheses has to equal 0. So, how would I do this? If I have a problem like this, where I have the stuff in parentheses that equals 0, I set up two equations. One where the stuff from the first set of parentheses equals 0, and one where the stuff in the second set of parentheses equals 0. And now what do? In each equation, I solve for x. So for my first equation, I subtract 1 from both sides, and that leaves me with x equals -1. That's my first answer. For my second equation, I can add 5 on both sides to get x alone, and that leaves me with my answer that x equals +5. For this second problem, same idea. I'm going to set up two equations. One is going to be 2x plus 3 equals 0. The other is going to be x minus 4 equals 0. For the first one, I need to get x alone, so I subtract 3 from both sides, which leaves me with 2x equals -3. Then I continue to get x alone by dividing by 2 on both sides. And that'll give me my final answer, which is that x equals -3/2. For my second equation, I simply add 4 on both sides. And we can't really see that well, but that gives me x equals 4. So now, if I'm given something like this, which is what you'll primarily be given, if you are given something like this, the question is, what the heck do you do? Well, you have to start out with step 1, which is factoring. So this is why we had a review day. You need to know how to factor. All right, so I'm just going to start out with A, which is 1, B, which is 8, and C, which is 15. Okay, remember that I am going to see the factors of A times C, which in this case A times C is 15, that add to 8, which is B. So if I look at factors of 15, I've got 15 and 1, and 5 and 3. Which pair of numbers adds up to 8? Hopefully you know this. It is 5 and 3. So 5 and 3 are the two numbers that I'm going to use. So when I'm setting up the box, x squared is going to go, or 5x is going to go there, 3x is going to go here. So remember that the 5 comes from this red 5 in the x. The 3x comes from the 3 over here, and they both need to have x because remember, they're supposed to add up to this 8x. Then I know my x squared can go in that first box, and my 15 can go in that last box. All right, another way that we can think about these problems is, okay, first find a GCF. What do x squared and 5x have in common? Oh, x squared and 3x have in common? X. All right, now, if you're not great with the GCF, you really just have to find it out for one row, and then you can try and puzzle out the rest of the box. So if there's an x out here, and there's an x squared in here, there has to be an x out here. All right. Here, if there's an x out here, and there's a 5x in here, I need to have a 5 out here. And then here, if I've got an x out here and a 3x in here, I have to have a 3 out here. All right, so you're just thinking. This is just multiplication. All right, you are using multiplication. So factored, this equation is going to turn into x plus 3 times x plus 5 equals 0. And then I am going to solve. So now that I have this as my setup, I will do my two equations, that x plus 3 equals 0 and x plus 5 equals 0, and solve for x. So I'll subtract 3 from both sides. I get x equals -3 for my first solution. Subtract 5 from both sides. X equals -5 for my second solution. I can go through this whole process again. Identify your A, your B, and your C. Okay? I look at A times C, which in this case is 1 times -14. which is negative 14. I want to find factors of negative 14 that add up to negative 5. So let me look at factors of negative 14, numbers that multiply together to make negative 14. I've got 14 and negative 1, but I could also have negative 14 and positive 1. Okay, so when you multiply to a negative number, remember, you get a negative number from multiplying a positive and a negative. So you have to consider both options. Negative 7 times 2 would give me negative 14, but also positive 7 and negative 2. So the question is, which of these numbers, pairs of numbers, would add up to negative 5? Again, you can use Desmos to check this, but you would get negative 7 and positive 2. So those are the two numbers that I'm going to use. So that means inside of these diagonals, I'm going to have negative 7x and 2x. And then in the other, I'm using x. Okay, I'm using x because these are, I forgot to change it to an m, but don't worry. It means the same thing. Okay, m, x, doesn't matter. It's a variable. Because I know some people are going to be like, why does it say x here instead of m? It means the same thing, guys. Okay, please. In the first, I'll have the squared term, and in the last, I'll have that number at the end, the negative 14, my c value. All right? X squared and 2x have an x in common, so I can take that out. X squared and negative 7x have an x in common, so I can take that out. Negative 7x and negative 14 are both divisible by negative 7. 2x and negative 14 are both divisible by 2. So factored, this equation would look like x minus 7 times x plus 2 equals 0. I apologize that it is so close to the bottom. I'm sorry, guys. So I set up my two equations. X minus 7 equals 0. X plus 2 equals 0. For the first equation, I add 7 on both sides to get x alone. It gives me x equals 7. For my second equation, I subtract 2 on both sides. It gives me x equals negative 2. So my two solutions are x equals 7 and x equals negative 2. Moving on. This looks different. Okay, what's different about this one is that now this doesn't equal 0 the way this one did, and the way this one did. Okay, so the question is, what do we do when it doesn't equal 0? Well, I have to get everything onto the same side. The only thing that is weird and out of place is that minus p, that negative p. So we are going to move it to the other side of the equal sign. How am I going to do that? Add p on both sides. This is going to change how my equation looks. Now the equation that I'm going to work with is p squared plus p minus 20 equals 0. Okay, so now this equation, now that it equals 0, this is where I'm going to get my a, my b, and my c from. So now I'm going to look at a times c, which is 1 times negative 20, which is negative 20, and see what adds up to positive 1. All right, so factors of negative 20, again, since this is a negative number, remember that I have to think a positive and a negative multiply to make a negative number, so I have to look at both options. So negative 20 and positive 1, or 20 and negative 1. Negative 10 and positive 2, or positive 10 and negative 2. Negative 5 and positive 4, or positive 5 and negative 4. So you can look at each pair of values and see which ones add up to positive 1. And if you use your calculator to do that, you will very quickly find that positive 5 and negative 4 are the values that do that. So in the diagonals, because I want them to add up to 1p or 1x, whatever, 5x and negative 4x are going to go in there. Again, I know it's not p. I know it's not p. It is x. It doesn't matter. Okay, they're just variables. They're just letters. Don't worry about it. In the other boxes, I'm going to put the squared term and the number at the end. Okay, x squared and negative 4x have an x in common, so I can take that out. X squared and 5x have an x in common, so I can take that out. 5x and negative 20 are both divisible by 5, so we can take that out. And then negative 4x and negative 20 are both divisible by negative 4, so we can take that out. Meaning that our factored form of this equation is x minus 4 times x plus 5 equals 0. So now, to finish up, I set up my two equations. X minus 4 equals 0, and x plus 5 equals 0. I add 4 to both sides. I get x equals 4. For my second equation, I subtract 5 from both sides. I get x equals negative 5. And there you go. Those are your two answers. Right? This one, again, looking a little different. It's not equal to 0, so I have to get that negative 18 to the other side. Add 18 on both sides. This is the equation that we are going to work with now. Okay? This is my A, my B, and my C. And again, I'm looking at factors of A times C, which in this case it's 36. 2 times 18 is 36. Factors of 36 that are going to add up to negative 15. Now remember, you can get a positive number, like 36, from multiplying two positive numbers together, or by multiplying two negative numbers together. Now here, I know that it's going to be by multiplying two negative numbers together because B ends up being negative. So I'm looking at factors of 36, but all of the pairs, all of the numbers and all of the pairs are going to be negative. Negative 36 and negative 1, those multiply to positive 36. Negative 18 and negative 2, negative 12 and negative 3, negative 9 and negative 4. So you can use your calculator to check which pair adds up to negative 15. Very quickly, you will find that it is this one, negative 12 and negative 3. So where do I put these? I put these inside the diagonals with their variable next to them. So negative 12x, negative 3x. Inside the first box goes that first term, 2x squared, and in the last box goes that last term, that 18. What do 2x squared and negative 3x have in common? An x. 2 and negative 3 cannot be divided by anything other than 1. That's all they have in common. But they both have an x. 2x squared and negative 12x, however, 2 and 12 are both, you can divide both of them by 2. And they both have an x in common. So I can take out a 2 and an x. Then negative 12x and 18 have a negative 6 in common. Negative 3x and 18 have a negative 3 in common that they can both be divided by. Now you might be wondering, hey, why is this negative? Why is this negative? Okay, also keep in mind it all has to work within the box. Yes, 2x has to multiply with something negative to give me negative 12x. Love it. And x has to multiply with negative 3 to give me negative 3x. So these values do have to be negative out here. And if you're wondering why, then just double check that everything multiplies on the outside to get what's in the box. So when I end up with my factored form, it is 2x minus 3 times x minus 6 equals 0. So I have my two equations, and then I just solve for x. So for my first equation, I add 3 on both sides. I get 2x equals 3. I divide by 2 on both sides, and I get my answer, x equals 3 over 2. For my second equation, I add 6 on both sides, and I get x equals positive 6. So those are my two answers. If you plug 3/2 into the calculator, it will give you 1.5. That's also fine. I don't care. Just know that this is also a version of that answer. Okay, one other way, just real quick. Is factoring the only way to solve a quadratic equation? Now, if you look at these are still quadratic because they have an x squared. Remember that quadratic just means that it has an x squared. So when I'm solving these equations, notice that they don't have a term in the middle with an x. When this happens, when I just have x, something with x squared, and then just some number that doesn't have another x with it, I can solve for x just directly, no factoring. So for example, for this first equation, I want to get x alone. I add 16 on both sides, and I get x squared equals 16. To get x alone, I can take the square root on both sides. Okay, square root of x squared, that would cancel out the squared, square root of 16. Okay, now if you do that, if you put that in the calculator, it would give you 4. But you have to think, squared means a number times itself. So that would mean 4 times 4 equals 16. But not just positive 4 times positive 4 gives you positive 16. Negative 4 times negative 4 also gives you positive 16. So when you solve these problems where you're solving directly for x, no factoring involved, you have to remember that when you get to the end and you take the square root, you have both the positive and the negative version of your answer. Okay, for the second example, let's see. I add 128 on both sides. 2x squared equals 128. Cool. X isn't alone. First, I'm going to divide by 2 on both sides. Okay, x squared equals 64. I take the square root of 64, and that gives me that x equals 8. Okay, 8 times 8 is 64. Negative 8 times negative 8 is also positive 64. So you have to take that answer into consideration as well. Okay, so before we finish today, you have to think, what does a solution represent? Okay, when does y equal 0 on a graph? And we kind of talked about this a couple lessons ago. But a solution is going to be the x-intercept on the graph. Solving when y equals 0 is the x-intercept on the graph. Remember this acronym, ROCKS. So these all mean the same thing. We can say roots, zeros, x-intercepts, or solutions. All those words mean the same thing. So if something says it's a solution, that is an x-intercept. If something says, oh, find the zeros, those are x-intercepts. Find the roots, those are x-intercepts. All of these mean the same thing. We're not going to go over the word problems today. That is for another day. But this is the end. Okay? Thanks for watching. Feel free to rewind if you need to. And have a great rest of your day.